Solving multiple step equations. The main skill we will employ today is moving the variables to one side of the equation and the constants to the other side of the equation. From there, division will often solve our equation. So some quick reminders of definition. A variable is an unknown. It's something that can change. So an example of this would be 2x or 3b or negative 4y. Those are all variables, whereas a constant is just something that is a specific number. It doesn't change. So the number 1 is a constant, or negative 5 is a constant, or 53 is a constant. Okay, so the main skill again, we're going to move the variables to one side of the equation and the constant to the other side of the equation. So let's solve this question. 2x plus 1 equals negative 3x plus 11. So let's move our constants. So we're going to move our variables this way. Okay, so how would we get negative 3x to the other side? Well, we do the opposite of subtracting 3x. We would add 3x. Okay, so that would give us 5x plus 1 equals, and the negative 3x and 3x would cross out, and we'd be left with 11. Now, we're going to move our constants this way. Okay, so how do we do that? Well, let's minus 1 from both sides. So that leaves us with 5x, and then plus 1 and minus 1 cross out, and 11 minus 1 gives us 10. So at this point, we now have the variables on the left side and the constant on the right side, and so we can use division to solve this. So x is being multiplied by 5, so the opposite of multiplying by 5 is dividing by 5. And now we have x, because 5x divided by 5 is just x, is equal to 10 divided by 5, which is 2. And the fun thing is we can actually check our work for a second. So let's just check this with x equals 2. So if you have 2 times x, which is 2 we said, plus 1. On the right side we have negative 3 times 2 plus 11. Well, 2 times 2 is 4 plus 1. Negative 3 times 2 is negative 6 plus 11. On the left side, we have 4 plus 1, which is 5. Oh, sorry. And negative 6 plus 11 is 5. And you'll see that that is true. Okay, second equation. 3 plus 2m is equal to negative 4m plus 15. So again, let's move the variables to the one side. So let's add 4m to both sides, because that will cross this out. Okay, so that gives us 3 plus, and 2m plus 4m is 6m, is equal to 15. Next, let's bring the constants to the other side. So let's bring the 3 to the right side, and that gives us 6m is equal to 12. As before, we want to isolate the unknown, which is m. So m is being multiplied by 6. So the opposite of that is dividing by 6. And we're left with 6m over 6, which is equal to m, and 12 divided by 6, which is equal to 2. And by the way, not all answers will be 2 in our work. These two examples do give us those answers. Okay, again, you can check your work. So 3 plus 2 times 2, and negative 4 times 2 plus 15. So that's 3 plus 4. And on the right side, we have negative 8 plus 15. And 3 plus 4 is 7. And negative 8 plus 15 is 7. And see that you have a true statement there. Now notice that you could isolate the variable on either side of the equation. So let's take that first question there. 2x plus 1 equals negative 3x plus 11. So let's move our variables this way instead. So we're going to subtract 2x from both sides. So that gives us 2x minus 2x. Cross those out, and we're left with 1 on this side. And negative 3x minus 2x is negative 5x plus 11. Now we want to bring our constants to the other side. So we do subtract 11 from both sides. And that leaves us with negative 10 equals negative 5x. And then negative 11 and positive 11 cross out. And then to get the unknown x by itself, we do the opposite of multiplying by negative 5, which is dividing by negative 5. So we do that to both sides of the equation. Now we have x is equal to 2. And see that we have the same answer. It just was worked at from a different perspective. All right, let's move on to some more questions. So when given brackets, we're going to start by expanding and then follow the steps above, which was collect variables on one side and constants on the other, and then divide to solve. So we have 5 times y minus 3 minus y minus 2. So we're going to multiply the 5 into both of these. So that's 5y minus 15. And if you have nothing in front here, what we can say is this is negative 1. So we're going to take negative 1 and we're going to multiply it by y, and negative y 1 times negative 2. So that's negative 1y, or just negative y. And then negative 1 times negative 2 is positive 2. We have 19. Let's collect our variables on the left side just to clean things up. So 5y minus y is 4y. And negative 15 and plus 2 is equal to negative 13. And we still have 19 on the other side. So we want to bring our constants to one side. So notice they're all on the left already. And now let's move our variables are on the left side already. So here's our variable. Now we're going to bring our constant to the other side. Again, it doesn't matter which side you bring it to, but just choose one side and slowly start solving. So we have 4y left, and then the negative 13 and positive 13 will cross out. And then 19 plus 13 is equal to 32. Then we want y by itself, so we divide both sides by 4. And we get y is equal to 8. Again, you can check your work, plug in 8 into the top equation, and what you should find is if you plug in 8 into this y spot and this y spot, that the solution will be 19. It should equal 19. Okay, let's try B. 2 times x minus 3 is equal to negative 3, x plus 5 minus 6. So again, we applied the distributive law. So it's 2x minus 6. Then negative 3 times x, which is negative 3x. And then negative 3 times 5 is negative 15 minus 6. Let's clean up both sides of the equation. So that's 2x minus 6 is equal to negative 3x. And negative 15 minus 6 is negative 21. All right, I'm going to bring the variables to the left side. So that gives me 2x plus 3x is equal to 5x minus 6 is equal to, and then negative 3x and positive 3x cross out and leave us with negative 21. Now we bring our constants to the other side. So we add 6 to both sides. We're left with 5x, and the positive 6 and negative 6 cross out. That leaves us with negative 21 plus 6, which is negative 15. Now we need to divide by the coefficient of the x. So we divide by 5, and we are left with x is equal to negative 3. And again, we can plug in x equals -3 into the question, and we should find out that the left side is equal to the right side. Okay, one last question here. A triangle has 3 angles such that the smallest angle is half the middle angle, and the largest angle is 2.5 times larger than the middle. What are the measures of all 3 angles? All right, I'm just going to draw a random triangle here. Triangle has 3 angles such that the smallest angle is half the middle. So let's call this one the middle one. I'm going to call this x. And it said that this one, the smallest one here, is half the middle. Actually, no, I drew this wrong, but I'm okay with that because it's part of the fun of this math. We use variables, we use unknowns, and then we solve, and then we can find the actual proper drawing. It says the largest angle is 2.5 times larger than the middle. So it's 2.5 times bigger than this x. So we'll do 2.5 times x. What are the measures of all 3 angles? Well, we're not given any information. How can we solve this besides some are bigger, some are smaller? Well, you'd have to use the angle sum of a triangle theorem, which says that the 3 interior angles of a triangle add up to 180 degrees. So I know if I call this A, B, and C, that A plus B plus C is equal to 180 degrees, assuming A, B, and C are the measures of each angle. So we'd have half x is angle A, plus B, which is 2.5x, plus C, which is x, is equal to 180 degrees. Well, a half plus 2.5 is equal to 3, and then 3 plus another x would be 4. So now we have 4x is equal to 180 degrees. If we divide all of these by the coefficient of the x, we divide by 4, then we get that x is equal to 45 degrees. And thus, the 3 measures are, so angle C is equal to 45 degrees because x is 45. Angle A is half of 45, and half of 45 is 22.5. Then angle B is equal to 2.5 times 45. And 45 times 2.5 is 112.5 degrees. And those are 3 angle measures.